Okay, so we've talked about what is the differential equation, and now the next piece that we're going to talk about is solutions to differential equations. And we're not actually solving them yet. There's really only one tool that I'm going to teach for solving differential equations. Well, I guess this could be a tool, considered a tool as well, but this is going to be just checking if something is a solution, because I haven't given us our tool to actually find the solutions. But what does it mean for something to be a solution? Well, it means that it's true. It means that an equation is true. So if we look at this here, we want to verify if y equals 4 cosine of 2x plus 6 sine of 2x is a solution to this y double prime plus 4y equals 0. Well, what are we going to do here? Well, we're basically just going to find y double prime and y, which we already have y, substitute it in, and we're going to see, is this equation true? So let's find y prime. Well, what's the derivative of 4 cosine of 2x? I'm going to do it really quickly. I'm going to assume we know our derivatives. This is negative 8 sine of 2x. What is the derivative of 6 sine of 2x? The derivative of 6 sine of 2x is positive 12 cosine of 2x. Doing our derivatives really fast. And now our second derivative, because we want to verify if y double prime is the thing, so we're taking the derivative of this. So y double prime, you can pause the video and try and figure out what the derivative is. I'm actually just going to write it once I get there, so pause it if you want to try and do it on your own. And the second derivative is y equals negative 16 cosine of 2x minus 24 sine of 2x. Okay, and now we want to verify if this is a solution. Well, I'm just going to take this y double prime, I'm going to substitute it into our y double prime. So I'm going to get negative 16 cosine of 2x minus 24 of sine of 2x. And then for my y function, I'm just going to take our original function y, so we have plus 4 times 4 cosine of 2x plus 6 sine of 2x. And I can already tell good things are going to happen. I don't know if you can tell yet, if you have an eye for it. But we're just simplifying this, and we want this expression to simplify to 0. We want this to be 0. And so distributing, this is going to be 16, so we're going to have 16 cosine of 2x plus 24 sine of 2x. And from there, it should be apparent what's going to happen. When we simplify this, negative 16 plus 16, that's 0. Negative 24 plus 24, that's 0. So this whole expression turns into 0. And boom, just like that, we verified that this equation is a solution to that differential equation. Boom, there's one. Second one, I'm going to zoom in a bit. Determine whether the given function is a solution to the differential equation. We're going to do this all same thing. Go ahead and try and find out on your own which of these are solutions, if any. Pause the video. When we come back, I'm going to go through it. And I'm going to go through it not super fast, but also not super slow. I'm going to do a medium pace. Okay, so coming back, looking at part A, we get f prime of x equals sine of x. F double prime of x equals cosine of x. Cosine of x minus negative cosine of x So this is our f double prime cosine of x minus, because I'm trying to verify if this is true, f double prime minus f, so minus negative cosine of x. That's going to give me 2 cosine of x. 2 cosine of x is not 0, so this is not a solution. So I'm just going to cross that one out. Okay, moving on to part B, the derivative of 2e to the negative x. Well, f prime equals negative 2e to the negative x, and f double prime equals 2e to the negative x. Because all that's happening is we're using the chain rule, so it's going to be times the derivative of negative x, which is negative 1. So negative 2, then positive 2. And then substituting this in, we get 2e to the negative x minus 2e to the negative x. F double prime, that's this one, minus f, that's this one. That gives us 0. So this one is a solution. This one is good. So I'm going to put a box around it. So this function is a solution. And finally, our last one. This k is just a constant again. So really, this one should be kind of obvious, hopefully, but taking the derivative of this actually doesn't change anything, because the derivative of e to the x is just e to the x, and it's just times this constant. So f prime equals k e to the x, f double prime equals k e to the x, and f double prime minus f, so k e to the x minus k e to the x. Well, that's just 0, so this is also a solution. And boom, there's that one right there. This one will require a little bit more work, but I gave us, well, we actually kind of needed multiple choice here. This equation is a particular solution to which of the following differential equations? Okay, so for this one here, I really just want to focus on sort of a testing strategy. So what I'm going to do is I'm looking and I'm seeing we have y's, we have y primes and y double primes. So let's find all 3 of those things first. Y is already given to us. We're going to change colors. Y prime equals 12e to the 6x. Y double prime equals 12 times 6 is 72 e to the 6x. 12 times 6, 12 times 5 is 60, yeah, so 72. Okay. So here's our first and second derivative. And I want to note something. The only constant that we have is with our y. And it's a minus 5. I'm going to use this as my testing strategy. The only constant is a minus 5. So if I'm looking, and maybe this actually won't help us. Okay, it will help us. If I look at this one here, where do I have a y? Well, I have negative 6 times y. So negative 6 times negative 5 is positive 30. So that's plus 30. So this is possible, just looking at our constant. This one is negative 12y plus 5. Well, negative 12 times negative 5 is positive 60. 60 plus 5 is 65. That's not 0. So I already know that b is wrong, just by sort of evaluating my constants. And here we have negative 6y. And that's just going to be positive 30, but there's no minus 30 here, so I already know C is wrong. So I can cross that one out. And finally, looking at D, we have y, our constant is negative 5 plus 5, that would be 0. So that's possible. So just looking at our constant, we can eliminate 2 of these things before I do anything else. And I did that because my y prime and my double prime don't have any constants. So this is sort of a testing strategy that I'm using. Now we can sort of just keep going with this. Let's look at this one first. This one looks a little simpler to do. Okay. So let's just do it by hand from there. We evaluated our constants. Our constants are 0. So now y prime, we'll do this one in green. 12 e to the 6x minus 6 times 2 e to the 6x minus 5 minus 30. I'm doing answer choice A in green. That's this expression right here. This is going to be 12 minus 12. That's 0. And we already did the constants go to 0. I already know the constants, so I don't have to worry about that. So this would equal 0. So A is true. Let's check if D is true. And I'll do pink for D. So y double prime, that's 72 e to the 6x minus 2 times 12 e to the 6x plus 2 e to the 6x plus 5 minus 5. Well, we checked that our constant works already, so this goes to 0, as I said. And I'm just sort of eyeballing it, and I can already tell. If you want to do the math, you can, but 72, this is negative 24, 7 plus 2. Like, this is not going to go to 0. I could figure out what it's going to go to, but it does not go to 0. I know that. And really, as soon as you know something, just work with what you know. Like, you don't need to get an actual number here. Like, if it helps you, if it gives value in some way to find this actual number, go for it. But if it doesn't give value, like, I know 72 is bigger than negative 24, and if I'm adding 2, that's not going to change anything. So this is not going to be 0. Okay, so A is our only solution there. And last question I'm going to do, I actually think these questions are really clever. I don't remember having to do many questions like this when I was in high school taking calculus, and I actually don't remember having. I know with limits and derivatives I had to do this, but I don't remember when I was taking I had took a specific course on differential equations. I don't remember having to do this type of thing. Although truthfully, my differential equations course wasn't the best course that I've taken. But okay, we want to find a value of k that will make this a solution to that. What do we need? Well, we need y double prime. So let's just start off. Let's stick with pink. I'm feeling pink is a good color for me right now. Negative 2k e to the, you can pause the video and try and do this. I'll wait a few seconds. Okay, that should have been enough time. Pause the video, you came back. And I'm sort of skipping steps here because I expect our derivative rules to be pretty good at this point. And yeah, so I'm not really going to explain the derivatives, but this is our derivative of this is our derivative of that. And let's substitute everything in. So we want y double prime, that's 4k e to the negative 2x minus 36 cosine of 3x plus 9y, so plus 9 k e to the negative 2x plus 4 cosine of 3x. We want this to equal 26 e to the negative 2x. So I'm actually going to write that there because we're going to end up having to solve for k. So I'm going to write what it should equal. And we'll distribute. And when we distribute, we get this, 9 times k e to the negative 2x, 9k e to the negative 2x, 9 times 4 cosine 3x, that's 36 cosine 3x. And we can see here that these two terms just disappear. They go to 0. And 4 plus 9, these are like terms because e to the negative 2x is their common variable. So 4k plus 9k, that's going to be 13k e to the negative 2x equals 26 e to the negative 2x. And you can solve this by inspection, but I'm also going to take it a step further. Like I can clearly see that what times 13 will get me to 26? Well, 2 times 13. K is going to be 2. But let's prove it mathematically. We're going to divide by everything around k, and I'm actually going to show this step. So we're dividing by 13 e to the negative 2x. And I'm actually showing it because there was a question on our final that required us to divide by e to the x or something like that. And I had a student that made a small mistake. So I want us to see what happens. 13 divided by 13, that goes to 1, so this goes away. E to the negative 2x divided by e to the negative 2x, that goes to 1, so this goes away. And all we're left with is our k on our left-hand side. 26 divided by 13 is 2, and e to the negative 2x divided by e to the negative 2x, that's a common factor that simplifies to 1. So we're left with k equals 2. And so what value of k will this be a solution to our differential equation? Let's do a dark blue. When it might be a really light blue for y'all though. I'm not sure. It'll be a discovery for both of us. Let's see what color it turns into. Oh, it is a really light blue. Okay. When k equals 2, y is a solution to the differential equation y double prime plus 9y equals 26 e to the negative 2x. Oops. Okay, and this is just how I'd write that sentence. Notice that this abbreviation, I wrote diff. You need to be able to figure out what I mean in this context. So diff is now short for like a lot of things. Diff can be short for difference, although I don't use the word difference that much. Diff could be short for differentiable, and diff can be short for differential. So differentiable and differential are two different words. I'm going to say it one more time so you can hear it. The first word I'm saying differential, that's this word right here, and then differentiable, the ability to be differentiated. Those are two different words. They have the same abbreviation. And my sort of clue that I'm talking about a differential instead of a differentiable is I put equation next to it. If you see like diff EQ, that's sort of your cue that you're talking about a differential equation. Diff EQ is like the abbreviation, the full abbreviation for a differential equation. So just something to keep in mind in terms of your abbreviations. The reader will understand the context as long as you make sense with the context. But yeah, thank you for watching.